half y equals log 2x. And so it could be a little bit weird, especially depending on what the base is, to try to put values of x in and figure out what values of y we get out. It's easier if we do exactly what we did in the warm-up and we write it in exponential function as an exponential form. So let's do that. I'm gonna rewrite the equation we're starting with, which is y equals log base 2 of x, and we're gonna put it in exponential form. What is the base of this log? 2, right? So we're going to take that 2 and we're going to make it the base of whatever's on the left side. That's going to give us 2 to the y power equals what? X. So all we did was write this logarithmic equation in exponential form. And now it'll be easier for us to just put powers in and get out x values. So normally we pick x values and we get out y values, but because we flipped it around, it's going to be easier for us to put in y values as the exponent and we'll get out x values. So we're going to come over at the table that's already kind of laid out for us. And we've got this same equation, and we're going to pick y values and let's see what x ends up being. And we just do it this way for the logs because, in my opinion, it's so much easier to do it this way than to have to fight with the logs. All right, so let's see what we come up with. When y is 0, we get 2 to the 0 power. Anything to the 0 power is 1. When we put 0 in for y, we get an x value of 1. That's a point we'll plot. The points are still x, y. We're not changing that. We just changed how we found it. But this point is still 1, 0. So when x is 1, we are right here at 0. Let's see what happens when y is 1. When y is 1, we get 2 to the first power. Any number to the first power is just itself, so our answer comes out to be 2. When x is 2, y is 1. That takes us to this point. Stop me if we're trying to figure something out. We'll go to the next one. 2 to the second power, y is 2. What is 2 to the second power?
4.
4, good job. So when x is 4, y is 2. And so kind of like the exponential functions we were doing, in this case, when x gets bigger, the graph keeps getting bigger in terms of the x powers. This last one, we'll let y be 3, and we get 2 to the third power, which it means we're multiplying 3 2's together, and we end up getting 8. And again, don't freak out with the math. You can, once you get like 2 to the power, you can just put that in your calculator. I'll fix it. And that one is way over here. When x is 8, we go up to 3. And then let's see what happens when we put in negative y values. When we let x be -1, we get 2 to the -1 power. And recall how we handle this. Whenever the exponent's negative, we got to flip it and bring the 2 to the bottom of a fraction. So this would equal 1 over 2 to the first power. That's how we make the exponent positive. And this just equals a half, or 0.5. So when x is 0.5 or a half, y is -1. Last point, when we put -2 in place of y, we get 1 over 2 to the second power, which equals 1 over what? One over 2 to the second power?
4.
4. Good job, Hudson. And 1/2 is 0.25. We go there. And so visually, this is what the graph looks like. Need to see something.
Well, I've already did like the previous 2 Alex assignments, like the one on like the unit 7, I believe. I think I'm already done with them.
Okay. All right. Have you done this one for today? Not yet.
Well, yeah, like the log.
The graph and the log.
Yeah.
Okay. All right. So you're on top of it. Good deal. All right, and this is what the graph looks like. So just a couple things that kind of change with this graph. This graph will keep slowly rising as we go to the right. And it's going to keep dropping as we go to the left. But even as we put in negative values for y and it goes down, the graph is not going to cross the line where x equals 0. Or in other words, we'll never get out an x value that equals 0. So a few things change with these logarithmic graphs when we have them in standard position. Our asymptote changes. So I said all that to say, for these graphs, we have a vertical asymptote where it won't cross the line where x equals 0 here. It'll keep getting closer and closer to where x equals 0, but it won't cross it. It'll keep going down. It'll get closer to where x equals 0, but it won't cross it. That's one of the main differences with these logarithmic functions. And we got some little keys, just some information about logs. The important one to note is, in standard position, the y-axis, where x equals 0, is a vertical asymptote of the graph, meaning the graph won't cross that line. On the exponential functions, the x-axis was 1, because the exponential functions were like this, and they flattened out this way. Or if it was a decay, it was like this, and it didn't cross the x-axis. Since these are inverses, that asymptote changes. So something to note as we graph these. You guys got any questions on this? All right, so a few things we'll do. We'll graph some of these basic ones just by finding a couple of points, just like we just did, and we'll graph them. Or we'll start with the graph as a parent function, and we might have to click it, and we might have to drag it and move it based on the transformations we see. And so just some little keys of what we did are right here. We put it in exponential form, and then it's kind of the opposite of what we've been doing. We picked y values, and then we got out x values. Let's look at another one. So we go to example 1. We got a graph that is in logarithmic form. Let's first write it in exponential form, just like in the do now, in the warm-up. So I'll just put just a step so everybody, when you look at your notes, this will make sense. We're writing in exponent form. So our base is 1 over 4. We're going to make that the base of y. And we end up with 1 over 4 to the y power equals x. My base was 1 over 4, so I made it the base of y. Everybody okay? Okay. And then we got to choose some values to help us plot it. And we're going to do just like we did before. We're going to pick some y values and we're going to get out some x values. And we'll want to pick y values that are pretty close to 0, just because we don't want the numbers to get too big or to get decimals that are too small that make it hard to graph. We might just do a little bit of thinking and thinking what'll make our lives easy as we do these. So I'm thinking we can probably do 0, because that usually comes out to being 1. And maybe we'll pick, how about we do positive 1, and then let's do negative 1. And let's see what values those give us for x. So we're going to take our equation. First, we're going to raise it to the 0 power. Anything to the 0 power equals 1. So that's our first point. When x is 1, y is 0. Let's graph that. 1, 0, right here. And then I tell you what, since we're not shifting our graph left or right, the asymptote should be right on the y-axis where x equals 0. So I'm going to just draw that line so visually we can already be kind of thinking about that. We'll have a asymptote at x equals 0. This line, the graph should not cross. Okay, let's find our next point. We're going to go and let y equal 1. We're going to put it into our function, and let's see what x value we get out. So we've got 1 over 4 to the first power. Any number to the first power is just itself. So this will equal 1 over 4. As a decimal, some of y'all would just like the decimal a little better. It equals 0.25. So when x is 0.25, we go up to where y is 1. So I'll just put it in between 0 and 1 for x. Just to be clear, that point is right here. It's in between where x is 1 and 0. And we're doing it by hand, so it won't be just spot on where we want it to be. But we're just doing a sketch. And so if I think about it, just thinking what the graph is doing, the x values are going to keep getting smaller as we put in bigger values for y. For example, if we let y be 10, and we do this to the 10th power, we'll end up getting 4 to the 10th power, which is going to be a very big number, and we'll divide 1 by that. So the graph is going to keep getting closer and closer to 0. So I can see it's going to go up, and I'm thinking it's probably going to go this way. Let's find one more point, and then we should be able to see what's going on. This time we're going to let y equal negative 1, and let's see what x value we get out. Oh, sorry. So we got 1 over 4 to the negative 1 power. And remember, with these negative exponents, after we distribute them, to get the exponent positive, we got to flip the fraction. So it will be 4 to the positive 1 power over 1, which comes out to equal just 4. So remember, the negative exponents, we got to flip the fraction to make it positive. All right, so when x is 4, we go down to negative 1. And as the y values get more negative, our graph will keep going to the right. So a little sketch of it. Would be something like that. So So last time our base was bigger than 1. So the graph was like this. Since our base is less than 1, the graph changed the shape of it, just like with the exponential functions. Our graph won't cross this line where x equals 0. That's our asymptote. And with these graphs, all we need are like 2 or 3 points, and that should be enough to get a sketch of it. And then the last things we'll do, we'll look at some transformations. So if this was the graph we had, like with any other graphs we've been doing, you can shift the graph up, and maybe it looks like this. You can shift the graph down. Maybe it looks like this. You can move it to the right. Maybe it looks like this. You can move it to the left, which also moves the asymptote to the left. And maybe it looks like this. We'll look at some of these transformations to finish up. Bless you. Since nobody else will.
Bless you. You're welcome.
All right, so in example 2, we have the parent graph laid out for us, and we're just going to transform this graph based on what we see. So the parent graph that we see here is y equals log base 2 of x. That's what this graph is we have below. This is the same one we did when we first started our notes. That means the other 2 things we see will be transformations. I see a -3 here, and I see a +2. These are going to be 2 transformations. Let's see what these do. And they work the same way everything's been working all year. So just to show you how you use this little graphic at the top, if I first want to see what this 3 does, -3, notice it's inside the parentheses being subtracted from x. Let's see what that is up at the top. So if I look, that's in the same spot as the c. So my question is, what does c do? C moves our function left to right. And since it's a horizontal change, it's opposite of the sign. It's opposite of what we think. So when we see -3, we feel like we should go left 3, but we actually need to shift right 3. And that's because of this 3 right here. Everybody okay, why we got to do that? We just followed the key. If you remember, we talked about it with the exponents. The formula is really x minus h. So if it's negative, that means the 3 is positive, so we go right 3. Let's see what the 2 does. 2 is being added to our function. If I go up and I look outside the parentheses, it's in the same spot as this. So let's see what it does. This moves our function up or down, and we go the same way as the sign. This is an opposite. So we see +2, we're going to go up 2. So this is how we're going to shift our graph around. We're going to take each one of the points and we're going to shift them right 3, up 2. Let's focus on this point right here, 1, 0. So from 1, 0, we're going to go up 1, 2, and we're going to go right 1, 2, 3. This puts that point right there. I'll look at the purple point on mine. The purple point is in between 0 and 1. It's 0.5, and it's -1. So I'm going to take that point. I'm going to go up 2. And I'm going to go right. 1, 2, 3. I'll move the green point, 2, 1. From 2, 1, I'll go up 1, 2, right, 1, 2, 3. And then our last point is this black point. 4, 2. I'll go to 4, 2, which is right here. Same thing. Up 2, right, 1, 2, 3. We probably could have just moved maybe 2 points and been enough to get a sketch of our graph. The more points, the merrier. So something to note, our asymptote was at x equals 0. But when we shifted the graph to the right by 3, the asymptote also shifts by 3. So our new asymptote will be at x equals 3. And that's because our whole graph shifted right 3, so the asymptote also shifts right 3. And so now with that in mind, graph is going down that way, and then I curve it up to the right. Okay, so if you're on technology and you had to shift the graph, you might click the button that lets you drag and move the graph around. Once you identify the shifts, you just click the graph and shift it just like we did. If I could pick this graph up off the paper and move it up to right 3, I would do that. Obviously can't do that, but on the computer you can do that. You can click it and you can shift it around. All right, one last one. So I want to show you just how to write this type in exponential form. Okay, so we want to write this in exponential form. Really all that's happening is this 2 is stretching our graph vertically. So this graph will be twice as tall as it normally would be in starting position. Let's put it in exponential form so we could find a few points in the table. So the first thing we got to do is get the log part by itself, and we need to move the 2 and put it on the other side. Since it's the log times 2, to cancel out the 2, we need to divide by 2. Since we do it on the left side, since we do it on the right side, we also need to do it on the left side. And so that's going to cancel the 2 out, leaving us with y divided by 2 equals our log by itself. And so now that we got our log by itself, we can take our base of 3 and make it the base of the left side and write it in exponential form. Don't overthink it. I know it's 2 things over here and that may seem intimidating, but we're going to take this whole thing and we're just going to make it an exponent. So 3 will be our base. And we'll bump up y over 2. And then this equals just what was inside the log x. All right, and this will be kind of like what we did. The only difference is We're going to take the y values and we'll divide them by 2 this time, instead of just putting the y value in. But that's okay, because we'll kind of think about what kind of numbers we want to put in, so we don't have to worry about fractions and stuff when we start to do this. So we're going to make a table just like we just did. We're going to pick some y values. And we're going to get out some x values. So in me thinking ahead, I think I want to pick numbers that we can divide by 2, because when we put them in, we'll want to get a whole number just to make our life easier. Yeah, probably 2, 4, 6, 8. I think we should put 0 in there, because at the top will just come out to be 0. And then I'll say maybe 2. And then let's do 4. Actually, let's do -2. Because the 2's will cancel out, it'll make it negative. And we'll see what happens when we put negative values in there. All right, so let's go to 0 first. We got 3 to the 0 divided by 2 power. That's just 3 to the 0 power. Anything to the 0 power is 1. So when x is 1, y is 0. I'll come on my graph. I'll go to where x is 1, y is 0. And also, just so I can think about how my graph should be moving, I'm going to go ahead and draw my asymptote on here. We don't have any shifting to the left or to the right, so the asymptote is just going to be on the y-axis where x equals 0. So my graph shouldn't cross this line. So I feel like it's going to be curving this way up, or it's going to come down and curve that way. Let's find another point, and we'll probably be able to see. This time we'll put 2 in. So we got a base of 3, and then we got y is 2 divided by the 2 that was already there. What is 2 divided by 2? 2 divided by 2?
1.
1, right? Anything to the 1 power is just going to be itself. So this comes out to be 3. When x is 3, y is 2. I'm going to go over to where x is 3. Then I'll go up 1, 2. And in all honesty, we've got enough points to see. Looks like the graph is going to be like this. So we could be finished. Let's just confirm it and find this last point. Our last point, we're going to put -2 in place of y. So we got 3 to the -2 power divided by the 2 that was already there. This is going to be 1 again, except since one of the 2's is negative, it'll be -1. And with the negative exponent, to make it positive, we got to flip it and put it at the bottom of a fraction. So what we end up with is 1 divided by 3 to the first power, which is just 1/3. So as we put negative values in there for y, it looks like we're going to get closer and closer to 0. Because when x is 1/3, we go down to -2. That point is somewhere right there. And for those who missed it, I put it right here. And so sure enough, it kind of falls in line. So let's curve through these points and draw a graph. It's getting closer and closer to the y-axis. And then it starts turning as we go back up. Right, so like I said, once you set this up, you can put this in your calculator. just like last time, and it'll give you the values you need. So you don't have to stress out about having to do all of these by hand, or you can put them in your calculator. It'll simplify for you. But those are the log functions. They're the inverses of the exponential functions. I think the exponential functions were easier to graph, so I think this way just makes our lives easier. Just remember, you pick the y values and you get out the x values. You guys got any questions? All right.